In this lesson, we're going to go over the equation of a circle. So down here, I have a circle of radius 3 that is centered at the origin 0, 0. What all this means is, if you start at 0, 0 and you go a distance of 3 in any direction, you end up on the circle itself. All those points together are drawn here. Now, what is the equation that you would enter into Desmos to actually get this picture? The equation is x squared plus y squared is equal to 9. If you put this into Desmos, it'll give you this picture. Now, where does this thing come from? And the answer is it comes from the Pythagorean Theorem. Let me show you why. Let's say you pick any point that falls on this circle. Maybe it's right here. It has an x coordinate and a y coordinate. I don't know what they're equal to. What I do know is that the distance from 0, 0 to this point here is 3. And that's what this information tells me up here. How can the Pythagorean theorem connect these things into this one equation? The way they are connected is by drawing in a triangle, which you can draw a line going down here and a line going over like this. So this is the triangle that I'm referring to. And this is a right triangle. In a right triangle, the Pythagorean theorem says that the square of this side plus the square of this side is equal to the square of this side. So what is this side and what is this side? Well, the length of this side of the triangle is actually the x coordinate. So this point here, to get to this point, you go over x and then you go up y. So this distance from here to here is what we call x. Likewise, the distance from here down to here is the y coordinate, which we call y. If we put all this information into the Pythagorean theorem, we basically get this formula here. I mean, it's really x squared plus y squared is equal to 3 squared, but these are the exact same formula. So this is the thing that I actually typed into Desmos to get this picture here. It is very easy to generalize this to any circle whose center is at the origin. The only thing that would change is if I picked a different radius. Like I could have said, what if the radius was 4 or 5 or 6 or really any number? If the center is at the origin, the only thing that's going to change is, well, instead of putting a 3 here, you would put a 4 if you wanted a circle of radius 4, and so on. So in general, for the equation of the circle centered at the origin, it is x squared plus y squared is equal to r squared. So this is a circle with radius r centered at the point 0, 0, which is the origin. But what if your circle is not centered at the origin? Like this here. Almost the same circle has a radius of 3, but let's move the center to the point 1, 4. So this is now the center of the circle. How is that going to alter the equation from the previous slide? So on the previous slide, when the center was 0, 0, it was simple. The equation was x squared plus y squared was equal to 3 squared. How will moving the center change this equation? I think we can still answer this by using the Pythagorean theorem. So let's say you picked a point here that falls on the circle. So it has an x coordinate and a y coordinate. But this time, this x doesn't mean this distance here. I mean, this x means you start here and you go over x. Likewise, the y that's here, it doesn't mean this distance. This y means, well, how far are you going up? We are still going to use the Pythagorean theorem to get the actual equation, and because of this, I'm going to draw in a right triangle. It's just going to be located a little bit different than the previous example. So the only difference here is that the point isn't at 0, 0, but it's here at the center, which is the point 1, 1. What we need to figure out is, well, can I figure out what this distance is? And likewise, can I figure out what this distance is? Because if you know these two things, the radius of the circle is still 3. So you could still say, well, the equation that will somehow connect all this stuff is going to be this side squared plus this side squared is equal to this side squared. So that's the goal. Figure out this length and this length. So x here represents how far you go from here to here. And here, this distance is always 1. So just drawing this down here. If you go from here to here, that distance is x. So that's from here to here. But this distance is 1. So that's this part of it. Going from here to here is a distance of 1. This part right here is just the leftover stuff if you took 1 away. So it turns out it's pretty easy to figure out this length. It's not equal to x, but it's x minus 1. And the reason for that is, if this is the point x, this means you've gone a distance of x. But if you subtract off this 1, you're left over with this length. Likewise, okay, what if I want to know this length here? Well, I know the distance from here to here is what we call y. So if I go from here to here, like this is y. But since the center is at a y value of 4, the distance from here to here is 4. So that's the distance from here to here. That's 4. So if you want this leftover stuff here, you can take the whole distance y and subtract off the distance 4, meaning this side is really y minus 4. If you plug all this information into the Pythagorean theorem says this side squared, so that is x minus 1 squared, plus, okay, then you'd have to add on the square of this side, which is y minus 4, is equal to the radius squared, which is 3, because that is this side squared. This is the formula if your center changes. Notice what happened. It's a very similar form, but what changed was the value here and the value here. If your center is at 1 for an x value, that just means you subtract 1 from that x value. If your y value here is 4, that means you just subtract that number from y. So in general, if you want a standard equation for a circle of any radius with any center, so I'll say a circle with radius r and center, we can use any letters we like, but maybe I'll use a variable h and k, then your equation is going to be x minus h squared plus y minus k squared is equal to r squared. So this h and this k were subtracted off of the x and the y values, so you could use the Pythagorean theorem. The equation of the circle in standard form is given by x minus h squared plus y minus k squared is equal to r squared. So r is the radius, and h comma k is the center. In examples 1 and 2, I'd like to write the equation of a circle in standard form given a radius and a center. Starting with example 1, we are told that the radius is 6, and the center h comma k is 3, negative 5. If we put this information into this formula, we have x minus h, which is 3 squared, plus y minus, well, it's minus a negative 5 squared is equal to 6 squared. So if you graph this thing in Desmos, you should see a circle with radius 6 and center 3 comma 5. We can simplify this a little bit. All I'll do is do minus a minus as a positive, and I'll square 6, so it is 36. So x minus 3 squared plus y plus 5 squared is equal to 36. This would be the simplified answer. It's not customary to square these out. In fact, written this way, it's very easy to see what the center is, and you can also figure out the radius too. Same idea for this question down here. Here the radius is the square root of 7, and the center h comma k is 0 comma negative 3. If we put this information into the equation of a circle in standard form, we get x minus 0 squared plus y minus a negative 3 squared is equal to the square root of 7 squared. This simplifies to x squared plus, okay, we get y plus 3 squared is equal to, and if you square the square root in this case, you're left with 7. And this is the standard form of this given circle. Let's graph this circle, x minus 5 squared plus y squared is equal to 16, and then from the graph determine the domain and the range. Well, to start with, I know the center is equal to 5, 0. These are the numbers that when you put them into x and y, make the part that is squared equal 0. So putting a positive 5 here makes it 0 squared, and putting a 0 here does the same thing. Now as for the radius, okay, the number we have here is 16, and that's equal to 4 squared. Therefore, the radius is actually 4. It is the square root of this number. All that being said, if you want to graph this thing, it'll be a little bit different in MyLab. In MyLab, there is a circle tool. You click on the center, and then you drag out until you get a point that is a distance of 4 away. By hand, what I'll do is note that the center is right here, so it is this spot. And I'm going to use 4 points that'll be enough of a guide to get the circle itself. So if we go a distance of 4 from this point, you could go 4 in this direction. So here's a point that has to fall on the circle. That's 5, 4. Another point is 4 in this direction, which is 1, 0. You also get, let's see if we go 4 in this direction, that's 5, -4. And then lastly, if we go 4 in this direction, we get 9, 0. I'll do my best to sketch the circle, but it goes through the points something like this. Not great, but you get the idea. It'll look better in MyLab. Okay, so here's my circle. What is the domain and range of this thing? The domain is all of the x values for the points on this circle. They all start here at 1, and they go until you get to here, which is 9. And we also include both of those points. So the domain is from 1 to 9. That's where this point starts up to where this point stops. So all of the points on the circle have an x value starting at 1 and ending at 9. Likewise, the range is all the y values. The lowest y value is here at -4. The greatest is at +4, and you get every single y value that's in between those two numbers as well. So for this reason, the range is from -4 to +4. So it's pretty easy once you have a sketch of the circle to determine these things, but that's it for this problem. In example 4, we want to find all of the points where the equations x squared plus y squared equals 36 and x plus y equals 6 intersect. So the approach is to figure this out by using a graph. So to start with, I'm going to graph x squared plus y squared is equal to 36. Now for that circle, it has a center of 0, 0, and a radius of 6. 0 and 0 make both of those terms equal 0, and the square root of 36 is 6. So that means the center of the circle is right here. Now if I want 4 points on this circle, so I can try to sketch it by hand, I'm going to go 6 in every direction along an axis from this point. So if I go up 6, this is the point 0, 6. If I go 6 in this direction, that is -6, 0. If I go 6 in this direction, that is 0, -6. And if I go 6 in this direction, I get the last point that I'm going to use on the circle, which is 6, 0. The equation of the circle will give me this thing as a graph. Not perfect, but close enough. Okay, well, what about the graph of x plus y is equal to 6? This is a line. What I'm going to do to graph this line is find both an x and a y-intercept. So that is, you put 0 in place of x and then solve for y. If you do that, you actually just get that y is equal to 6. This means the point 0, 6 is the y-intercept of this equation. But that's actually this point right here. So there's the point 0, 6. This point is common to both the circle and the line itself. That's going to be one of the answers to this question. Okay, let's find the x-intercept. That is, we let y equal 0 and then solve for x. Okay, if we put 0 in place of y, we get x plus 0 is 6, or simply x is equal to 6. That means we have the point 6, 0. But that is this point here. It's another point that's on both the circle and the line itself. If I try to sketch the line that goes between these 2 points, I get this thing here. I can see from the picture there are only 2 solutions. There's only 2 places where these 2 equations meet. Okay, one is at the point 0, 6, and the other is at 6, 0, and I can see that there are no others, and that is it for this problem.